The temperature at which a normal conductor becomes a superconductor is called as the critical temperature or the transition temperature, which is denoted as Tc. Now let us see a few examples for which tin, mercury and lead. The critical temperature for tin is 3.7 Kelvin and the critical temperature for mercury is 4.2 Kelvin and the critical temperature for lead is 7.2 Kelvin. Something which is very important to remember is the superconductivity is a reversible process. Okay, now let us see a practical graph for the mercury. As the temperature and the resistivity against the graph is being plotted for the metal mercury, we can see at 4.2 Kelvin it start conducting superconductivity. That is when the y-axis is like 0.01 and the x-axis is around like 4.2 Kelvin. Okay, the condition for temperature for superconductor will be T, which is lesser than or equal to Tc, and the condition for temperature for normal conductor is Tc, which is greater than T. And the magnetic field for superconductor, that is H, should be lesser than Hc, and the magnetic field for normal conductor is H greater than Hc. Now let us see the properties of superconductor. Zero resistance. It means the current will be flowing forever when once it is step up, but it is opposed by the property 2, that is the critical current density. Critical field strength, that is denoted as Hc. It is possible to convert the Hc to normal conductor by applying the magnetic field. And the isotope effect. What is an isotope? The atoms are same. The element which have same atomic number and different atomic mass are called as isotopes. And the Meissner's effect, as we have already discussed previously in the previous video. Now let us plot a graph which is K, that is T versus H. That is the temperature versus the density, field strength. And now if we plot a graph of T and H, we get at the end we have the Tc, as we all can see here. Let me zoom it up. And we can see here this is H0 and this is Tc, critical temperature. Below this we have superconductors and above this we have normal conductor. So in between this region, that is between this temperature and between this field strength, any metal will act as a superconductor, and above this temperature and above this field strength, it will act as a normal conductor. So this is a graph which depicts the performance of any metal. We can take any metal as an example and we can actually plot this kind of graphs. And for that we have a formula also, where Hc is the critical field strength and H0 is the field strength which is obtained after plotting this, and H is the entire y-axis will be taking, and T is the entire x-axis will be taking. Tc will be the critical temperature. And now we can see the formula which we have to use. Hc equals H0 1 minus T by Tc, the entire whole square. This is called as the Meissner's effect. where Hc is the external field which has to be applied in order to convert the superconductor to normal conductor. As we already discussed, the superconductivity is a reversible process. By applying this external field strength, we can convert the superconductor to a normal conductor. That's all about for this video. Thank you.